Let's go through it one more time now and see if you gain something this time. What is the name of the electric generator?
Sodium, potassium, pump.
What turns it on?
ATP.
ATP. What do you have to make ATP? Glucose plus oxygen. What is the source of glucose? Fruits, vegetables, and sprouts. What produces lack of oxygen at the cell level? Trapped blood proteins. What traps your blood proteins physically? Shallow breathing and improper exercise. Nutritionally, foods that damage cells and make you thirsty. Mentally, anger, loss of temper, holding grudges, and resentment. Did it mean more to you that time? You gain something. Every time you hear it, you gain. You think, why do we repeat and why do we repeat? One person said, boy, it sure repeats a lot. Another guy turns and says, you know, I know a certain book that does the same thing. And you wonder how you keep going back every week to hear the same thing over and over, you know. Anyway, you know, just find out that sometimes repetition, and you keep saying it and find, oh, that time I got it. I gained more. Till finally you say, well, I thought I had it, but I didn't quite get through the door yet. And there it is. And so finally, we get through. Let me bring out one other thing. Before we leave the nutrition, I want to talk about one more element of this thing. Let's go to page 52. I want to talk about wrap up just a few things before we reach we're backing up to the nutrition concept here just a little bit, and then we'll wind up on the physical now. We're going to talk about some of the diseases that we have and understand some of the causes of these diseases. We go into, for example, we take the first one is obesity up here. And we say, what is obesity? Can you blow up some balloons easier than you can others? Yes or no?
Yes.
We now believe some people's bodies are the same way. We believe that some people are born with a loose cellular structure and just a small amount of trapped proteins in a person's body can blow him up like a balloon. That's why we say a person who has what we call lymphedema, which is obesity is a form of lymphedema, when you understand it. It's a fluid retention. And how come at that loose structure you can have stress and gain 2 inches while you just sit there and watch it? You can exercise and get going, and you can lose it and come back down. Okay? And it can happen. You go up and down, you can starve and starve and starve. You can come down, fine. All you have to do is eat anything over here. Eat any of this stuff. Any of these foods that damage cells and make you thirsty, and you come right back up again. You'll come right back up, and you can feel it. You feel it. You sit there and watch it, and you feel it just blow you up just like a balloon. It's tough. From this chart on page 52, how many gallons of water can you hold inside of your trapped blood proteins? The top gallons is what? 21 gallons inside of it. That's like putting 2 10-gallon cans inside of you. Okay? Now, a person with a loose cellular structure has a rough time. And if they're born with that condition, if with that weakness, they need all the love and understanding you can give them. Not criticism, not ridicule, you see. We talked about that. But all the love and understanding you can give them. Nobody needs more. But they've taken all the love out of obesity in the United States. With all the magazines, everything that's out, all it is ridicule, 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 condemn, condemn, condemn. Make them feel like they've got to spend every dime they've got to make themselves physically appealing to people who are just as sick as they are. True or false?
True.
Is that justified?
Yes. No.
Okay. We all need help. You see, we all need help. Not that they don't, but everybody does. If we had energy, how far could you run? 150 to 200 miles. Now that's health. That's not being perfect. That's just being healthy. That's health. Health is what? Health is energy. Right. Now, let's take high blood pressure. We'll talk about high blood pressure now. High blood pressure is called the silent what? Killer. Why? Because you can't see it. The little guy who has a tight cellular, who looks like he's healthy, is breaking the laws just like the big person is, right? He's getting trapped blood proteins out there with excess fluid, and the fluid pressure out here in that little guy can collapse his vessels on both sides. It collapses his bloodstream, and it can go right into high blood pressure and heart disease. Now, a little guy looks perfectly healthy could drop over dead, leave 6 little children behind. It happens all the time. True or false?
Sure.
Can the little guy be just as sick as a big guy?
Yep.
He gets obesity, he gets heart disease, he gets cancer, he gets MS, arthritis, he gets it all, right? Okay, now we've talked about the high blood pressure, heart disease. We've talked about the infections. We went in here to show that in this state the white blood cells could destroy the cancer cells. And I wanted to show a picture of that, but it's in the case. We do have a picture of the white blood cells destroying the cancer cell. But in order for the white blood cells to work, the research says they have to have the close contact of the cell. In that condition, you cannot have cancer. It's impossible. Because your immune system can destroy the cancer cells. You can't have viral infections, bacterial infections, or allergies. And even microorganisms become parasitic in lack of oxygen. Okay? But when you get over here, then you have the lack of oxygen, then you have the excess fluid, and your immune system falls down. Then you have the viral infections, bacterial infections, and the allergies, and the cancer. Okay? The inflammation and the fevers. Now, here we go. Remember I told you I talked about spontaneous human combustion, people burning up? The fever is a sign of that. It's a small thing. When you upset that sodium-potassium pump, when you upset that chemical balance, that sodium-potassium pump goes into spontaneous firing and the heat goes straight up. Like that. The body's electrical, right? If you take a house and you generate it down to a certain point, can the electrical wiring go haywire and put the house on fire? Okay. And you ask yourself a question, what's happening here? Just show. Didn't know if I'd do this for sure, but let me show the picture. This is an artist's rendering of spontaneous human combustion. This was published in Science Digest. It was published in October 1981 in Science Digest. And I picked that up at the newsstand in the airport, and I had this on the plane. I was looking at that picture, and a fellow standing next to me says, "Hey, that's real." I said, "What do you mean it's real?" He says, "My buddy was dancing with a girl, and she burst into flames and dropped into ashes right in front of him." I said, the flames come out of her head and her back, and this kind of started right there. He said, "That is real." And I said, "Wow, you mean it's real?" And spontaneous human combustion is the name given to a phenomenon whereby the human body apparently erupts into a blazing inferno without contacting an external fire. In some accounts, the whole body is reduced to ash while nearby combustibles remain unsinged. Now, once you understand that the body is electrical in nature, then things begin to make sense. It's a freak thing when it happens. When that sodium-potassium pump goes into spontaneous firing, the heat goes zoom, and if that lines up just right in our body, it goes whoosh, and it's electrical. And bones and all go. Now keep in mind, you cannot destroy the bones in a blazing furnace. If you try to cremate a person, the bones are left over. You have to pulverize them. In this thing, the bones are gone. We had Don Gosnell went in to see Dr. Bentley, and he come running out and said, "Dr. Bentley burned up." And here's what's left of Dr. Bentley. The rest of his body was in ashes, but there's a leg and a foot and a shoe left. And the rest of him is gone. Keep in mind, you cannot destroy the bones in a blazing furnace. And if you look real close, the rubber tips of the walker is still there. They burn from the inside out. And in many cases, even the bed they're laying on is not hurt and the body's gone. They burn from the inside out. That is spontaneous human combustion. Is cancer a hotspot? Yes or no?
Yes.
With this research, we're saying cancer is to be destroyed by a slow burning fire. Is that true or false? Is cancer a hotspot?
Yes.
It is an electrical short circuit. The only thing that can alter that electrical field is what? Blood proteins. That's the only thing that can alter that electrical field. And when you alter the sodium-potassium pump, it goes into spontaneous fire and the heat goes straight up. Now, if that thing lines up just right, it can burst into flames and drop into ashes, right? So cancer, scientifically speaking then, is to be destroyed by a slow, moldering fire.
Would you just repeat that?
Okay? Okay, quit.
The part about...
And the blood proteins come out and alter those electrical fields. When it alters the sodium-potassium pump, when that pump gets altered, it goes into spontaneous firing when the chemical balance gets upset. It goes into spontaneous firing, and the heat goes straight up. There is your hotspot. And all diseases are a hotspot. How many know that? How many know that? How many know if they can photograph the body now, Here we have a brand new technique that they do it with radioactive elements, and they put it on a TV screen, and it goes right in and it finds the hot spots in the body. All diseases are a hot spot. All diseases is the protein altering that electric field, and the sodium potassium pump goes into spontaneous firing, the heat goes straight up.
What magazine do you have?
This is the Science Digest at May 1982 in this particular edition. This is the May one. This is the May issue. Okay. I might maybe if you want to see one or two more. This was given to me in Canada. People they published this in Canada, quite a bit of it here on spontaneous human combustion. They showed a blazing furnace, and they said you can't destroy the bones there, but here the bones are gone. Here we have a skull and a hand and leg left. In this particular picture here, here's Dr. Bentley again here. But this one here is really something. Here we have the lady's head, her shoulder, and her arm. The rest of her body's gone. There's the head and the shoulder and the arm. The rest of her is gone. Now, those are not nice pictures to look at. Okay. Yes?
I don't understand. You said that these problems are hot spots, and yet you said, how do we combat that with a smoldering fire?
You don't this isn't combating it. I said cancer is a hot spot. Then to be destroyed by cancer is to be destroyed by a slow-burning fire.
Yeah, I thought you were saying to destroy cancer. You
No,
use a
okay.
slow-burning
I'm
fire.
glad
That's
you
why
brought
I
that
had
up
to
then.
repeat it.
Cancer is a hot spot. Therefore, scientifically speaking, to be destroyed by cancer is to be destroyed by a slow-burning fire, because the body's electrical. Now, when you think of it that way, and 1 out of 3 is getting cancer, and they say it can go to the doctor saying if we don't stop it, it's going to go to 1 out of 1. I just ponder that. Okay? Yes.
You mentioned fevers. Now, are you saying that a fever is a result of an overactive pump? Or are fevers, I've read, like fevers, by raising the temperature, it enables certain enzymes to be produced that help the body.
The fever, the first sign of inflammation. Inflammation is a hot spot. The first sign of inflammation is trapped blood proteins, and that's right out of Guyton's text. The trapped blood proteins, you see, the only thing that can alter that field, you have to alter the sodium potassium pump to get the hot spot.
So on fevers, that's what I meant.
That's
Do
right.
you let fevers go, or you're trying to administer something that
You do something to perspire, sweat it out. Do something to, you don't suppress that, you sweat and get the poisons out. And when you get those poisons out, then the fever goes. But it's the poisons producing the dilating capillaries, causing trapped blood proteins, shutting generators off in your body, causing the fever. You get the poisons out and it stops.
What would be a danger signal for someone to notice they're too hot inside?
This is a freak thing. Let me say about spontaneous human combustion. When I showed these pictures in Israel to the doctors there, some of them have never seen them before. But this is the first scientific explanation that makes sense out of what we see. Gives us a believable explanation on what is taking place. Okay? It is a freak thing for that to happen. I mean, for this thing to line up just right, and some people, they say they have to be heavy alcoholics on top of it and things like this, where they've got their body loaded with deals and generators shut off through the whole system. They used to think it was the alcohol causing it. Well, indirectly it might have been. The alcohol shutting generators off all over and happens and spontaneously goes, okay? But, or other things. But they have found it happening with going down the road in cars, waving and zoom it goes, walking down the street or skiing, or it's happening from various ages, from little kids on up to older people. So about 200 cases, and so nobody knows.
There's no danger signs?
No. There's no danger sign. But it's a freak thing. Don't worry about it, because I understand there's no pain involved. Yeah, there's no pain involved. The girl I talked, the woman I talked to in California that had her whole back hot as can be and sweating, and says, "I'm burning up. I'm hot. I'm hot." And they wondered. They run in the ladies' room there, and they took off her clothes because wondering, and there she had all second-degree burns, blisters all over her body. But she said, "I didn't feel a thing." She didn't feel a thing. And it's a weird thing. She says it didn't. And the people who see it, they walk in the pictures and they see flames coming out of a person's back, and they'll be surprised. The person down the floor doesn't feel it yet. And yet when they see it out and stuff, they try to stop it. It's a freak thing. Okay, there's a lot of things we don't understand. Somehow, when that happens, everything goes haywire as far as the nerves, and everything goes haywire. It's just a whole new concept. But The thing of it is to understand it's just interesting to comprehend that diseases are hot spots, and now we can know why. Okay? It makes sense out of what they're finding in the research and in the literature. Okay, now we go to arthritis. Now arthritis is simple. Okay, now we've got the pain and cancer. Pain is lack of what? Oxygen. Unoxygenated blood cannot relieve pain. Say it. Unoxygenated blood cannot relieve pain. Okay, now the arthritis. You get the sodium potassium pump is calcium, iron, and minerals and nutrients inside that cell. When you alter that sodium potassium pump, the calcium falls out of solution. It's the pump that brings calcium, iron, and minerals and nutrients. When the blood proteins come out and those electrical fields get altered, the sodium potassium pump gets altered, then the calcium falls out. Then you got the arthritis, the calcium deposit. Well, guess what? If you can go in and reestablish that chemical balance, even with foods, where you eat the good food and to get the glucose and the oxygen and turn those generators back on, the calcium can come right back into solution and the joints can go perfect. I have seen it happen. I have watched it happen. Okay? It comes right back into solution. That's arthritis. Now we've got MS and polio and so forth. Muscles work electrically. If this happens in muscles and interferes with the electrical impulses going to brain and muscles, you got MS and polio. Okay? I know what Dr. Joseph Waltz is doing in New York. He's putting electrodes down the spine. We're now understanding it. He's moving the cluster proteins out. The excess fluid comes out. The excess sodium comes out. They're getting oxygen in there, turning the generators on, and they get up and walk. Making sense now? Okay. That's fantastic. Any questions on that before now we go into the exercise part and the physical part more in detail? We'll teach how to exercise, no fatigue, and go into pain relief techniques. Any questions before we do that? Yes.
How do we know which foods are good to eat for whatever it is that's ailing us?
What is your source of glucose? Come on. Fruits, vegetables, and sprouts. Now watch. Isn't it interesting? The blood's almost all water. It contains dissolved minerals and nutrients. Here the minerals and nutrients come out of the blood to irrigate the cells. The cells takes the minerals and nutrients out of the water, and the dead water is cast out. So we have to replenish those waters and that water and that mineral all the time, right? Now, what food are we going to eat that's almost all water that contains dissolved minerals and nutrients? Fruits, vegetables, and sprouts. That's it. If you have fish, have meat, have poultry, and fish, okay? But protein is not the best source of glucose. Because
What about raw juices?
your seeds and grains sprouting. They're better sprouted, okay? Yeah, you can't lose weight on bread. You just can't.
What about vegetable juice? Is that okay, or have you changed
Great.
it?
Fantastic. Your juices are fantastic. I want to show you one more chart. That's on page 288. And I'm going to let you read that in the text. And if you have any questions afterwards, we'll be glad to talk about it. And it'll be the same for those who show the tape to the rest of them just. And it's how hypoglycemia turns into adrenal diabetes, pituitary diabetes, and goes right into high blood pressure and heart disease. Okay? It's on page 288. Yeah, because you got a first edition. This is second edition. Okay? Adrenal diabetes, pituitary diabetes is a battle between the adrenal gland and the pituitary gland, which takes place when you do not eat enough fruits, vegetables, and sprouts, and you're still not on a high-protein diet. You're eating junk food, more or less. You're eating just junk food. Most people eat junk food today, right?
Correct.
You're eating junk food.
We live on
And when that happens, you go into hypoglycemia, low blood glucose. And so you have a battle take place. And
When I did that, they put me on
high protein. Shall we spend just a minute and hit that? Please? Okay. All right. We will spend just a minute. And I don't want to belabor this because this can take time. Let me do it real quickly, and then you can read the book and get it, okay? Now I'm going to go through it slow and easy, and let's just do it. And then you can read those pages because it tells you what page between 116 and 120 in the book, and it's there. Once I explain it to you, I think you'll understand it. Okay. If you're not on a high-protein diet, if you're not eating enough fruits, vegetables, and sprouts, you have to have that glucose from somewhere. Then the body's going to go to the cell to get it. It's going to go the protein out of that cell to get it. What happens is that the adrenal gland puts off cortisol, and if you'll notice there on that chart, it shows that on the one on the right. Improper diet. The adrenal gland puts off cortisol. The cortisol takes the protein out of the cell to the liver to convert that protein to glucose for the cell. because that cell has to have glucose. Now, glucose is the fuel for the cell. Protein is for building cells. Now, to give you an idea how much protein we need, what I mean by high protein diet, let's ask one question to solve that. How much protein does the body require? Let's ask a question. If protein is for building cells, let's think. What is the percentage of protein in mother's milk? 1%. Now, think about that. A little baby nurses a mother, and it doubles and triples in size on mother's milk. Now, if protein is for building cells, regardless what the percentage of protein is in mother's milk, that is the maximum amount of protein this human body would ever have to build cells. Make sense? I mean, when would you need more protein to build cells when we're doubling or tripling in size if protein is for building cells? So whatever the protein is in mother's milk, that's the maximum. Well, isn't it interesting? We have 2.38% at birth, and it drops down to 1.2 to 1.6 in 6 months. And the baby still doubles and triples in size on that. And if you go to page 225 in the book, I won't do that right now, but if you go to page 225 in the book, you'll find that we have the same percentage of protein in green leafy vegetables and baked potatoes as you have in mother's milk. That the source of glucose is also a source of what? Protein. Now I'm going to show you and give you evidence so you'll understand that every long colon animal on the face of the earth, now everything with a long colon, their source of glucose is their source of protein. When a calf gets off a cow, where does a calf go for protein, glucose, and minerals? Grass. Where does the cow go for protein, glucose, grass. And yet we think we have to eat the cow. Okay? Now, where does the horse go for protein, glucose, and minerals? Vegetation. You take the strongest animals on the earth. Let's take the elephant and the gorilla. Two of the strongest animals on the face of the earth. Where do they go for protein, glucose, and minerals? Vegetation. In fact, every animal with a long colon goes to vegetation for protein, glucose, and minerals. Isn't it interesting that we have a long colon? That the only animals who eat meat have a short colon. Why? Because with a short colon, you can get rid of the poisons produced from breaking that protein down. There are poisons produced. When you take the protein to break it down to get glucose out of it, poisons are produced. And if you have too much of that, it's going to damage the liver and it will damage the kidneys.
Excuse me.
But if you take a short colon animal, now watch, the short colon animal, it can take care of those poisons, and with a short colon, it can pass them out and get rid of them, yes.
Are cats then a short colon animal?
Anybody answer that for sure?
They
All
nice.
have to be because they eat.
Yeah.
That's their soul, really, naturally.
Cats eat mostly meat, but they're very similar in
They're
structure to
carnivorous.
dogs, which eat.
Have you ever seen people raise cats and dogs on vegetation?
No way.
They don't like it. They're gonna have.
Guess what? I have been in homes where they do it. Totally. Totally. I have been in homes around the United States where they raise their animals, and
When they're sick, they go to that, I know that.
I know that. And it's interesting. I've been in homes where they do. But what we're talking about here, that every animal that eats meat has a short colon, because then they can get rid of those poisons. Our colon is 2/3 too long. Before that protein, the meat gets to our colon, it'll putrefy. The poisons will dilate our blood capillaries and let those blood proteins come out, and it'll cluster and trap them out there. It makes you thirsty to the falls.
True.
Okay. Now watch what happens again. Let's see, I didn't want to take too much time with this, but watch how it works. If you're not on a high protein diet, you're not getting enough fruits and vegetables, then the adrenal gland puts off the cortisol to take the protein to the liver, to convert that protein to glucose. Now, when the adrenal gland does that, then the pituitary gland sends out the growth hormone. And that growth hormone says, that protein's mine. I need this for reproduction. You can't have it. That's nice, except the growth hormone won't let the glucose in. It has a side reaction. It has a side reaction to it. So when the cortisol takes the protein out to the liver to convert it to glucose, the growth hormone comes in to protect the protein, but it will not let the glucose in, so the glucose builds up in the blood. And you go from low blood glucose into high blood glucose, and it can put you on a roller coaster that can send you almost insane sometimes. It wreaks havoc with the brain. The brain has to have glucose. And boy, when you go no glucose and too much glucose, and back and forth, the brain goes havoc. And it can send people almost insane. Mentally. This can cause real mental problems. Now, this is called adrenal diabetes or pituitary diabetes. It is high blood sugar because of the battle between those two glands. Okay? Now, when you get too much sugar in the blood, the pancreas out there says, get out the insulin. Get that sugar out of the blood, because too much sugar in the blood can cause problems. Well, in time of this going on, the insulin-producing cells in the pancreas get burned out. And then you turn into diabetes mellitus, or permanent diabetes. And that's how hypoglycemia turns into adrenal diabetes, pituitary diabetes, and ends up with permanent diabetes. And then as the sugar keeps building up in the blood, it also is connected to fats in the blood. And too much fat will rob the oxygen from the red blood cells. The red blood cells come to the capillary single file. When you rob the oxygen from the red blood cells, they stick together or cluster in that bloodstream, just like the blood proteins cluster out here. Just like the blood proteins cluster here. Those red blood cells in the bloodstream will cluster in here. It will block it and dilate those blood capillaries, and out comes out the blood protein, and in time they will cluster out here, and as they cluster, the fluid pressure out here goes right into high blood pressure and heart disease, as the pressure collapses the bloodstream inside.
Now, is permanent diabetes reversible by diet?
You never know. You never know if those cells are actually destroyed or are the generators just shut off because they're damaged. When you go in and turn the generators on, if you start producing the insulin, then you know that's what it was. But you never know what you try. Yes.
Are you going to go into the high-protein diet? What happens when
Okay, now, why does the high-protein diet make them feel good? While it actually kills them. The high-protein diet, let me show you, it is not a cure. True or false? The high-protein diet is treatment. It is not cure. Now, why does the high-protein diet do what it does? All right, now all at once I put in high protein in from the mouth. I'm going to shove it in. It's a very poor source of glucose, but I'm going to put a lot of protein in at the mouth. If I put in high protein in from the mouth, then the adrenal gland will not put off the cortisol to take the protein out of the cell, will it?
No.
There won't be any need for that if I stuff myself with protein. Now, if the adrenal gland doesn't put off the cortisol, the pituitary gland doesn't send out the growth hormone. So it bypasses that battle. So here I get the protein coming in. It goes to the liver, breaks down to glucose slowly. The glucose goes into the cell, and boy, do I feel great. Man, I've got energy. I'm coming out of this thing. It's just great. While the poisons produced are damaging the liver and the kidneys. And that's why it says if you've got bad liver kidneys, don't take it.